y'all. Today we're going to talk about some statistics. I'm going to start with a little bit of vocabulary and then get into normal distribution and a bell curve. And there's also a video that'll be linked that you should watch to learn a little bit about the bell curve. And then we'll do some practice with it. So again, just a little bit of statistics to wrap things up as we are winding down this semester. So here are some vocabulary words. Simulation. Is an imitation or representation of a potential situation or in experimental testing. So it's not the real thing, it's just kind of representing make-believe what you think will happen in an actual experiment. A survey, gathering of a sample of data or opinions considered to be representative of a whole. You do surveys all the time. Someone may give you a sheet of paper, ask you some questions, you're doing a survey. These days, a lot of our surveys are electronic. Observation, a remark, statement, or comment based on something one has seen, heard, or noticed. We make observations all the time in our daily life, what things look like, what we hear, what we see. We're making observations all the time. An experiment, a situation involving chance or probability that leads to specific outcomes. So you might have done different kind of experiments in one of your science classes or maybe any other class, like just some sort of experiment to see what will happen. A random sample is a sample in which each individual or object in the population has an equal chance of being selected. Again, the key word is random. So there's no rhyme or rhythm to it. It is totally random. All right, so this idea of normal distribution. So again, I have a video that is linked here to YouTube that will explain a little bit more about normal distribution. Okay, so normal distribution, a function that represents the distribution of many random variables as a symmetrical bell-shaped curve. So it's symmetrical, so you can imagine a line right in the middle here. This side is going to be 50% of the data, and then this side is going to be 50% of the data. Or your bell curve can be a little skinnier, but it's still wherever your peak is, that's going to be 50% of the data to the left side, and then this is going to be 50% of the data to the right side. The graph of the normal distribution depends on the mean and the standard deviation. Mean is the average. So I normally do like average heights in class. We can do arm length. We can do just some different things. You can take data, add it together, and find the average. Your average is going to be in the middle of your bell-shaped curve. Whether your bell shape is a little wider like this or a little skinnier like here, wherever your average is, not wherever, the mean will always be in the middle. Wherever your mean is, to the left of that would be 50% of the data is less than the mean, and then 50% of the data is greater than the mean. The mean determines the location of the center of the graph, so I just talked about that. The mean goes in the center. The standard deviation determines the height of the graph. Standard deviation is how far you stray away from the data. When the standard deviation is small, the curve is tall and narrow, like the one over here on the right side. That means that most of your data is close together. When your standard deviation is large, it's going to be short and wide, like this one over here. That means most of your data is spread out and is far apart. So we're going to go through and do some examples dealing with bell curve and normal distribution. All right, so example 1. The heights of the 880 students at East High School are normally distributed with a mean of 67 inches. It has a standard deviation of 2.5 inches. Approximately, how many students are more than 72 inches tall? The first thing you want to do when you're given these kind of problems, you're looking for keywords like the mean or the standard deviation. You want to go ahead and draw your bell-shaped curve. So I've already drawn mine in. Of course, you can pause the video if you need it. But the first thing that you want to do is draw your bell-shaped curve. When you draw your bell-shaped curve, a few things will never, ever change. First of all, your mean will always go in the center of your data. Other things that will never change, this will always be plus or minus 1 standard deviation above or below the mean. So whatever your mean is, this will be 1 standard deviation to the left, meaning it will be lower than the mean. And this is going to be 1 standard deviation above the mean. And this will always be 34% on each side, adding together to give me 68%. This will always be 2 standard deviations from the mean. So notice this is my mean. I went down 2 standard deviations, so they're going to be below the mean, and this goes up 2 standard deviations. And this last one is going to always be 3 standard deviations from the mean. So this is 1 standard, and I'm going to abbreviate 1 standard deviation. This is going to be 2 standard deviations, and then this last one is 3, and I messed up there, STA, standard deviations. So I abbreviated there. So wherever your mean is, you can go minus 1 standard deviation, minus 2, minus 3 standard deviations, and then I can go up 1 standard deviation, 2 standard deviations, 3 standard deviations. So your mean always goes in the middle. These percentages will not change. It'll always be 34, 13.5, 2.35. These percentages do not change. All right, so let's see what all this means in the context of my problem here. So a few words to let you know when I use the bell curve normal distribution here. That's a key word. If it says something about mean, or if it says something about standard deviation. So all 3 of those are keywords that, hey, I needed this bell curve, I needed these percentages, this is what I need. So the first thing we want to do is put our mean in the center of our data. So the mean goes here. Up here it says the mean is 67. So I'm going to put 67 right there. Your mean always goes in the middle. Now it says it has a standard deviation of 2.5. So I'm going to take 67, I'm going to subtract 2.5, subtract 2.5 again, subtract 2.5 again. Then I'm going to add 2.5, add 2.5 again, add 2.5 again. So 67, I'm going to subtract it. It gives me 64.5. Subtract it again, that gives me 62. Subtract again, that gives me 59.5. Now I'm going to add 2.5 because that's my standard deviation. That's going to give me 69.5. This is going to give me 72. And then the last one's going to give me 74.5. And all of these are inches, 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 inches. Okay, and let me zoom in a little bit. So what I did in the problem, it gave me the mean. It told me the mean was 67, so I put that in the center. And it told me my standard deviation was 2.5. So I subtracted 2.5, subtracted 2.5, did it again. And on the right-hand side, I added 2.5, added 2.5, added 2.5. Now, the question says approximately how many students are more than 72 inches tall? I see 72 is right here, so I'm looking for this data right here. So that is the part that I'm interested in. So how many people are taller than 72 inches? Now, I know that this section is 2.35%. I need to figure out how much space is left over here. So I know that my total percentages need to add to 100. So I know that when I add this, it should give me 100. So I've already done that. When you add that together and subtract from 100, you're going to have the space on this side and the space on this side. So again, I added all of these up. Subtract from 100 and divide by 2 because it's symmetrical. So you got to have some percentage over here, and you're going to have a percentage over here. So this little space that's missing is 0.15%, and same thing is missing on this side. Again, one more time, I added everything up. Percentage has to add to 100. I subtracted these from 100 and divided by 2 so I can get the space that's left over on this tail end. The question wants to know approximately how many students are more than 72 inches tall. Well, I can add these 2 percentages up. So 2.35% plus 0.15 gives me 2.5%. Now, the question doesn't want to know what percentage of students are taller than 72 inches. It wants to know how many students. So up here, I can see that there are 880 students at this school. So if we just do 880, change your percent to a decimal, and you get 22 students. So the answer to this question is 22 students. There are 22 students in the school that are taller than 72 inches. All right, we're definitely going to go through and try another one. So we're going to start with our bell curve. We're going to draw that. We're going to fill in our standard deviation numbers and then go from there. All right, number 2. A machine used to fill water bottles dispenses slightly different amounts into each bottle. Suppose the volume of water in 120 bottles is normally distributed with a mean of 1.1 liters and standard deviation of 0.02 liters. Part A. Approximately how many bottles of water are filled with less than 1.06 liters? Part B. What percent of the bottles have between 1.08 and 1.14 liters? So what I've already done is drew in my bell curve. These percentages do not change. They're exactly the same numbers as the example from above. So go ahead and draw your bell curve. It's always going to be 34, 13.5, and 2.35. So these percentages will not change. I'm still going to do the plus or minus 1, 2, and 3 standard deviations so I can get my points that I'm looking for. So here we go. Up here in the problem, it says that my mean is 1.1. So again, keywords that I see mean, I see normally distributed, and I see standard deviation. So that's leading me to believe that I need to do this bell curve shape. So the mean is going to go in the middle. My mean is 1.1, so that's going to go in the middle. My standard deviation is 200. So I'm going to add or subtract this on both sides. So I'm going to add to both sides, add to both sides, add to both sides. And then I'm going to subtract it from both sides. So I'm going to subtract, and subtract. Now that I have everything I need, I'm going to zoom in just a little bit so we can see our bell curve a little bit more. So the mean always goes in the middle. I added 3 standard deviations. We subtracted 3 standard deviations. Okay. Part A, approximately how many bottles of water are filled with less than 1.06 liters? So we're going to look and see where we see that. I see that right there. So I'm going to highlight this. So this is the section that I'm looking for. I'm looking for anything less than this over here. So I need to figure out what this little random space that's left over here is. And of course, this isn't drawing to scale, so of course it probably should be a little tinier, but we can get the gist here. Just like we did with the first example, we're going to add everything up, subtract from 100, and divide by 2. It's going to give us the exact same number. And this is a symmetrical bell curve, so I can put that in. So what I did, I added up the percentages that we had, subtracted it from 100 and divided by 2, and it gave me the little tiny space that was on the tail end of the problem, of my bell curve. Now it says approximately how many bottles, approximately how many bottles of water are filled with less than 1 and 600 liters. So I'm going to add these percentages together, which we did do in the previous problem, but I want to show that step again just for studying purposes. So I got 2.5%. So this space here is 2.5% when I add it together. I don't want to know about percentage. I want to know how many bottles exactly. So my total bottles up here in the problem is 120. So there are 120 bottles total. So I need to do 120 times, change that to a percent. Change it to a decimal. And when I multiply that, I get 3. So the answer for part A is 3. So we did 120 times. We changed it to a decimal. The decimal was right there. Move it 2 places to the left. So 120 times that, we got 3 bottles. And part B, what percent of the bottles have between 1.08 and 1.14 liters? Well, I see those on my bell curve. So I see 1.8 is right here. And I see that 1.14 is right here. So we just need to add these 3 percentage numbers together, and that'll give me the percentage that I'm looking for. So we're going to add 34 plus 34 plus 13 0.5. Add that all together, and I got 81.5%. All right, so this has been a little bit of statistics and the bell curve.